everybody. I hope you are doing well. In this video I'm going to explain how the image is created in the concave mirror. We have 4 cases. Actually, for the concave mirror we had 6 cases, but I'm going to explain 4 of them. When I explain this 4, you will be able to learn the other 2 also. In this video I'm going to draw an image. For example, look, it's written over there. It's written if the object is at C. If the object is at C, the image will be at C and real inverted same size. I will draw the object, and by the specific rays for the concave mirror that we learned in the previous video, we will be able to draw the image. First of all, let's put the object. Let's think that the object is an arrow at C. That's the point C, and I will draw an arrow over there. This arrow will be the image, the object. That is going to be an object. Let's change the color to be more clear. Okay. That is the object over there. This arrow is an object. That is the object. What we said for the first thing that we said, if we could send the light straight, to the mirror, it must hit the surface of the mirror and reflecting back through the focal point. As you see, according to the rule, it must reflect back through the focal point. A little down. That is the reflected ray. Second rule, we said if we could send the light through the focal, it must reflect back from the parallel way. Let's just draw send the light through the focal. Look, I will draw the line through the focal. It must be reflecting back through. It must be reflecting back as a straight line. Look, it must reflect back as a straight line. Okay. I draw 2 lines. That is the first one. That is the second one. According to these 2, I can understand that the place of my image is at point C. Because I take 2 lines from the head of the object, so this intersection must be the head of my object. Look, that is going to be the head of my object. How do I know that? Because all the light hits the mirror and reflected back at the same point they intersect. Reflected back, after they reflect back, they intersect at the same point. Guys, if I draw the third one, what we said for the third one, we said if we could send the light through the center, because the object is at the center, I cannot send it through the center. But if I send the light through the pole, if I be able to send the light through the pole, I can see the light is going to hit the mirror. Let's just make a little bit straight. Okay. It's going to hit the mirror and reflecting back through the pole. We said that the pole, it must be walking like a plane mirror. As you see, I draw the third line, the third one also. I draw the third one. 1, 2, 3. All of them intersected at one point, which is going to be the head of my object, the head of my image. That's going to be image. So according to this image, I see that. Look, that's the first cell, second one, first and second. So it must be the same size. same size, and it's inverted upside down, yes, as you see that, and it's real. Why? Because it's in front of the mirror, in front of the mirror, in front of the mirror, or it comes from the real intersection of the reflected ray. Okay, that is for the case when the object is at the center. What if we put the object, what if I put an object at between focal and center, between focal and center, anywhere that I like, I can draw it. I can put the object over there. Look, I will put the object. That is an object. This arrow represents an object. Let's say that's object. Object. Now, first of all, what we said if you send a light straight or parallel to the optical axis, it must hit the surface and reflect it back through the focal. That is going to be focal. That's going to be the focal when the light is going to hit it. Okay, that is the first ray. For the second ray, let's change the color to be more clear. Second one, what we said, if you send the light through the focal, it must hit the surface and reflect it back straight, reflected back parallel to the optical axis, I can say. Look, here is it. I just found the intersection point between these two rays. I found the intersection point. That's the intersection point. When I see this intersection point of the reflected ray, I can say that is the place of the image. So I can say that if I draw a straight line, this straight line will be the image of my object. This straight of line, it will be the image of my object, as you see. So now, that is going to be the head of my object, the head of my image. Look, that's an object, that's going to be an image. 2 ray is enough to detect the place of the object, because I will have, by 2 rays, I will have the intersection point. So that is enough if I draw 2. If I make it 3, if I send a ray through the center to the mirror and reflect it back, the same way it will hit this point, another one, and it's going to be hitting the surface of the mirror. But because of my mirror is small, I don't need to draw this one. And look, the image is beyond C. It means it's at the behind of the C. That's the center, that's the behind of the center. This is the behind of the center. That is inside of the center, that's outside of the center. And because it's formed from the real reflected ray and it's in front of the mirror, it's real. And for C, it is inverted, as you see that it's upside down. It is upside down. The image is upside down, but the object is not. And it's written magnified or bigger. I can check that this is 2 cells for the object, but for the image I have 1, 2, 3, and more than 3 cells. That's why I can say it is bigger. Okay. Now I will come for the third case of the making image by the concave mirror. If the object is at focal point, will I be able to have an object or not? Let's put the object at this point. Let's put the object at this point, and I will be able to draw an image. That is an object, and this object object. And what we said, first rule, we said when you send the light straight, it must hit the surface of the mirror and reflect it back through the focal, guys, through the focal. As you see, I'm going to send it back through the focal. Not exactly through the focal, but I send it through the focal. And the second one, we said if you send it through the focal, because the object is at the focal, I cannot send it through the focal. But I can send it through the center, or I can send it through the pole. Let's send it through the pole, it's much clear. That is the pole, I send it, and it must be reflecting back like a plane mirror. This angle must be they must be equal to each other. Guys, as you see, I draw two lines. I didn't have any intersection point. Do I have any intersection point? No, I don't see any intersection point. And these two lines are totally parallel to each other. So it means if there is no intersection point, like this point, like other point, it means there is no image. There is no image. So the image will be at infinity. So I can say no image. No image. And it's real. If there is an image, it's going to be a real because it's in front of the mirror. Okay? So at the point inside of the spoon, if you have a spoon, just put your finger near to the focal point, near to the inner side of the spoon, you won't be able to see your finger. So it means your finger at focal point. The last case which is we have, is so much important. If you have an object between focal and between focal length and between the pole of the object, between the focal point and the pole of the object. If I have this object, and that's an object, that is the head of the object, I'll say that is an object. Now, what we said, if you send a straight line from the object to the mirror, it must hit the surface and reflect it back through the focal point, right? That's the focal point and must be reflecting back through this point. I have to be so accurate to have the intersection point. That was the first one. For the second one, I'll change the color to be clear. Okay. For the second one, what we said if you send the light through the focal point, it must be reflecting back straight, right? If you send the light through the focal point, it must be reflecting back through that is the focal point, and that's the head of the object. I could send like this. So that's sending through the focal to the object, hitting the mirror, and must be reflecting back straight. As I see over there, I draw two rays. First one send it parallel to the optical axis and then to the mirror, reflecting back through the focal. Second one sending through the focal to the head of the object and reflecting back straight. I see no intersection point from this part. There is no intersection point. There is no intersection point. You might say this is the intersection point, but actually it's not, because one of them is the real ray, the second one is the refracted ray. What I will be able to do that, I will just draw some imaginary lines, some dashed line, just like this. I will draw some dashed lines. Okay, and I will draw some dashed lines for this one also. And I will be able to see that there is an intersection point from the imaginary lines. There is an intersection point for the imaginary lines. Look, that is the intersection point. So this intersection point, it will be the place of my image, and I can just draw an image. We said the image must be like this, and that's going to be the head of the object, head of the image, sorry, and this is going to be the back side of the mirror. So that is an image, that is an object. Now look, the image is behind the mirror. Yes, it is behind the mirror, and we have the intersection point from an imaginary lines. That's why the image should be virtual. That's why we call it virtual image. And it's upright, it's not upside down. As you see, the image is not upside down, and it's bigger. As you see, this is 1.5 cell, but this one is much bigger. So that is the how the image is created in front of the mirror and the behind of the mirror, especially when you have a concave mirror.